All right. Hello, everybody. Like you said, my name is Brandon. I work on Instagram, and specifically, I work on the Instagram engagement infrastructure team based out of New York. And today, I kind of want to just give a user story about like how we use Spark at Instagram, and kind of cover three topics. One, our use case, what we use Spark for, how we've changed those pipelines over time, and then thirdly, different things we think about when managing Spark at a very massive scale, and I'll get into the details about that. So as I mentioned, I work on the engagement infrastructure team, and engagement as a whole for Instagram is focused on basically every way a user can consume and find content on Instagram. So be that your traditional feed where you follow people and see content, other products like Explore or Stories or Search. Engagement, kind of as the whole team, is focused on all of those user experiences. And then specifically the infrastructure team that I'm on as part of engagement, our job is to provide services and data to the rest of the organization so that all of us together can kind of improve those experiences for the users. And one of the important driving factors that we have in engagement is that users want to see relevant content. And so I have this quote: "See the moments you care about first." This was actually the title of a blog post in March of 2016, which doesn't seem that long ago. But this was the announcement that Instagram feed was going to move to a ranked feed experience versus traditionally chronological. And this caused some waves. But by a ton of different measures, since then, this has been very positive for the user experience and very positive for the entire ecosystem on Instagram. So how do we do that? We provide a ranked experience to all of our users. Well, the first problem you run into is this, which is a very big number. If you're not aware, we just recently announced we have over 800 million monthly active users on Instagram. I believe of which 500 million use the service every day. That's a lot of users. That's a lot of requests. That's a lot of data being logged from our services. And so we needed something that could process all of that data and in a timely fashion. And to provide good services to that many users, we obviously must rely on machine learning. And I kind of want to give like a brief overview of like the machine learning lifecycle. You may already know this, but this is kind of relevant to our talk. First step, you start with training examples, and you train a machine learning model on top of that. And then you use that machine learning model or multiple models at runtime to make predictions. So in the case of Instagram feed, we have a set of media that we want to show to the user. We want to decide what order in which to show that. And then from there, you want to measure the outcomes that happen afterwards. So in our case, maybe a user taps like on a certain piece of content, or maybe there's a negative signal, like they report a piece of content as being spammy. So all of those things, we want to log that as well. And out of that becomes two different data sets, what I'll call ranking events and client events. And then we use Spark to combine those two things in a very large join, which then we generate new training examples from in order to retrain our model. And then it's kind of like this life cycle. That's how you improve your models over time for machine learning. So you might be wondering, like, why Spark? I mean, this is a Spark conference, so that's a good question. But all the typical reasons you would expect: better performance. The traditional way to do big data applications inside of Facebook is to use Hive and Hive queries. We noticed that as data scaled up, Hive tended to perform worse and worse for our use cases. And so we decided to start testing with Spark. And we actually have a Spark team inside of Facebook that's focused on actually doing auto migration of Hive queries to Spark as a compute engine. And they found that CPU performance running the same exact SQL queries tends to be much better on Spark. So it just shows how well Spark performs in terms of CPU time. And then also being able to test modular components of your pipeline. Specifically, our pipelines are written in Scala, using the dataset API now. And it's very important for us to be able to test the individual components and have reusable components, obviously modularity. We also wanted to provide the ability for our different teams inside engagement to have custom logic. And so we've kind of created some abstractions to make that easier for them as well. And then one of the most important things was moving to serialized logging. And there's a couple different reasons for this. So I want to give an example of something you might log from your service. So let's say this is a candidate that you ranked in your service. It has certain scores from certain models. You used features from those models, or rather used features and those models to kind of make a prediction. And so, a JSON version of this might look like this. And it tends to get very inefficient in terms of like storage space. You obviously have to store keys and strings, and these are basically just giant string blobs, which tends to get very inefficient, especially when you're dealing with 800 million users. And so inside of Facebook, we use Thrift for serializing most of our data. And so you could also represent this as like a Thrift struct that has these fields, which then becomes very compact when you serialize it. And then when you're writing code to deal with this logging data, you can just interact with it like a normal object in Java. So being able to do that, writing our pipelines in Scala and dealing with Java objects, it becomes very powerful and very natural to deal with objects. There's a little bit of peculiarity dealing with Java objects in Scala because of like collection types, but for the most part, it's been okay for our use cases. So how have we changed things over time? I kind of mentioned Hive a little bit. That's kind of where we started. We had like unstructured logs and not serialized. That only scaled so far. And then we started to move to Spark, and specifically we started with RDD. This was at a time when I think data sets and data frames were still like experimental, and this actually worked very well for us. Certainly performed better than Hive. But again, we started to run into scaling issues a bit, particularly in memory usage. And so you would kind of go through this cycle where we're dealing with data that's coming from like user requests, so the data is changing day to day. And so you can imagine a case where like the pipeline fails because it runs out of memory, and so you then go back and you increase the memory, and then you hope that it continues to succeed, and then like it fails later on. So it's like this like never-ending cycle. And so we decided to make the transition to using the dataset API because it was stable and we heard good things. And in doing that, we got much lower memory utilization and actually much better performance. In one specific example, we had a pipeline that we rewrote from using RDDs to datasets using the same logic, and it ran about 6 times faster, which in our case, our pipelines are taking on the order of hours, so that actually makes a difference. Obviously, you get lower memory requirements. Datasets give you compile time checking, which is huge as a developer, obviously. And then we also make use of mixing SQL and actual code using the dataset API. And it's very powerful to be able to do that for different use cases. And so we've enjoyed that. But then we kind of went further and created this kind of higher level abstraction called a training data joiner. And this is specific for our use case of joining those 2 data sets I mentioned, ranking events and client events. And we wanted to make it very easy for other teams inside of our organization to utilize Spark. And so we came up with this concept. And basically all it is like a parent class that you can extend. So this is a very simple example where all the user has to do is define the labels that they're interested in. And this has a whole set of utilities in the parent class that does the joining, it does the parsing from the tables, it deserializes the thrift structures and all these things, and it kind of takes away a lot of boilerplate for this specific use case. And then the user would also like define their output as a case class. And this is basically all they have to do. They can define different functions to calculate different labels. So again, things like a user liked a piece of content or they reported a piece of content. We have a lot of ranking engineers and data scientists that are experimenting with different ways to do these. Do this ranking. So you can imagine there's a whole host of ideas that they come up with. And yeah, this was an abstraction that we came up with. It's very easy for them. And as an infrastructure team for engagement, like we kind of sit in between our customers, which are the ranking teams, so like the feed team and explore team. We sit between them and then like our core infrastructure team, like the Spark team at Facebook. And so it's been very easy to kind of sit in the middle there and provide services to our customers to make their lives easier. And then I want to talk about how do we manage massive scale. Obviously, like I said, we're generating a lot of data. In the title of this says 300 plus terabytes. That's pretty typical for an instance of our pipelines. We're also, I mentioned feed specifically, but we're expanding ranking to other products within Instagram as well. And it's been a good experience so far, so we want to keep doing that. And I kind of split this up into 2 separate categories. The first of which I'll call people. And what I mean by this is just like having a big team. You can that comes with a set of challenges, having to deal with a lot of people making changes to your code base. And Instagram as a whole and Facebook as a whole has grown massively in terms of employees, even in the past year. And so we needed to come up with ways to make sure that people kind of weren't stepping on each other's toes. And the main advice I have here, which has actually been very easy for us to do, is to automate everything. We're lucky in that this is very core to the culture of Facebook, and so we've been able to leverage a lot of his existing tools and expertise. But basically automate things like testing, code formatting, building deployments, how you run these pipelines in your production cluster, how you create clusters in the first place, as many things that you can kind of abstract away for your users and for yourself, it becomes better, and you can kind of focus on the high-level problems. And then another thing I already kind of mentioned was just having simple interfaces. I mentioned creating this parent class for this training data use case, but we've also done other things with our different sets of data. And so as an example, you can kind of imagine an interface like this, where you just have a case class of ranking events, and you want to read that data, do some stuff with it, and write it out. And so our team kind of implements a lot of these for our different data sets. We have these utilities like this, which again make it very easy for our users to deal with using Spark at a higher level. And then obviously on the other side of massive scale, there's the data. I mentioned 800 million users, several hundred terabytes of logging data is, again, very typical. And first and foremost, what I would mention here would be to plan for growth. We've had cases where, because our customers are other teams, they're doing a lot of things, and Facebook's very much about moving fast. And so we don't want to limit other teams in what they can do. But in some cases, that can mean that a new feature gets turned on and your logging size doubles overnight. So you need to plan for that. You need to make sure that you're understanding the product teams and what their plans are. And then also in terms of just organic growth of your service. In the abstract for this talk, I mentioned 700 million users, and since then we've announced 800 million users. So for Instagram specifically, there's this exponential growth. And it's very important. It's nice when you're running in if you're running in a cloud environment where you can just spin up more resources. If you're not in a cloud environment, you need to kind of plan further out and to make sure that you can handle the capacity. And then also stress testing your systems. You can tune your configuration for today, but in a month when you have more users, it may just explode. So that's something to keep in mind. And related to growth, one of the things that actually helped us specifically for our Spark pipelines was persisting data to HDFS, for example. And what I mean by this is, depending on what your pipelines are actually doing, if the very first step of your pipeline filters out a bunch of data, like we had a specific case like this, we would filter out about 80% of the data. And then you have downstream processing where you join and do further things with this very long pipeline. Because our pipelines are running for a long time, on the order of hours, if something happens to fail downstream, so if a task fails in the join step, it's very nice that Spark can recalculate data from upstream, but if your very first step is filtering out a bunch of data, you're then going back up the lineage and recalculating a bunch and throwing out a bunch of data. And so that can kind of get wasteful, and it can cause your pipeline to run even longer, which you may run into more problems. So I have kind of an example diagram here. If you're source data and you do mapping and filtering and you do a join, a very simple way to kind of alleviate this is just kind of insert this temporary table. It doesn't come without cost, obviously. You have to store that data. And there's also, obviously cost in serializing and deserializing. But we've actually found this to be one of the most important things we've done as we've scaled up. Because also when you do this, you can tune the different stages of your pipelines. They basically become separate pipelines at that point, and you can tune those pipelines independently. So things like memory usage, or number of executors you're running, or the number of partitions you use. When you do this and you kind of understand how the data is flowing through your system in these different stages, it becomes more powerful to be able to tune those and make them more reliably independently. So that's been huge for us. And then next up would be enabling KRYO serialization. You may already know this, but KRYO replaces just normal Java serialization. It's much faster, it's more compact. And particularly enabling this configuration flag called registration required. And what this does is it allows KRYO, when it serializes your data, it allows it to use a lookup map for the class names instead of encoding the actual string class name in the serialized data. So you can imagine if you don't have this enabled and you don't have your class registered, every row that you have a class serialized will have that string name in it, which gets very inefficient when you have many rows. So by enabling this flag, at runtime, it will actually throw an exception if you try to serialize a class that's not registered. And that kind of sounds bad, but it's actually good. It's a feature, not a bug, because it forces you to register all of your classes and make sure that they're being encoded in the most efficient way possible. There's a caveat here in that if you do enable this, some internal Spark classes are still not registered, which is something that can be fixed. And you can register them yourselves as well. But as an example, if you do a broadcast join and have this flag enabled, you'll probably get some exceptions. You just have to add some of the internal classes. So something to think about. But again, it's very useful to make sure that you're serializing in the most efficient way possible. And then next up, Big O, taking us back to computer science fundamentals. Who would have thought that this matters? But I kind of feel like Scala specifically can be kind of magical at times, which is why I love the language. But it can also allow you to do things that are not efficient without you knowing. And so you can do all these wonderful transformations and then find out that you have very inefficient code under the hood. So my point here would be to make sure you understand what your code is doing. And profile your code and test these things. This becomes very important as you scale up and you're calling functions, millions or billions of times. Like, these things actually matter. In one specific example, we had code that was using a Scala enumeration, which you should not use. And if you don't know why, you can Google the phrase "Scala enumerations must die" for a good discussion. But this code used an enumeration, and in particular, it tried to find a value based on its string name. And there's this very useful function called withName, which has the caveat of this line right here, which does a linear scan through every single value in your enumeration in order to find the correct one. And if your enumeration has a lot of values, like ours did, this becomes very inefficient. And so this is just like a very typical linear search when you can replace with like a hash table to do constant time lookups. So it kind of takes us back to, again, CS fundamentals, but things like this actually matter when you're working at a large scale. And then related, data structures. I feel like I'm teaching a course at university. These also actually matter at scale. And in particular, a lot of our use cases use map structures, and the different map structures have different performance guarantees under the hood, and so it's important to understand what your application actually needs. And in particular, Scala has some more performance-optimized versions of maps. So an anyref map, an int map, long map, et cetera. And then there's also this fastutil library that you can utilize, which has very performance-conscious collections that you can use. And a specific example here, we had a piece of code and a utility function that was getting called many, many times, and it just used a built-in map. And we replaced that with an int map, and the performance increased by about 15 times. So again, things like this matter when you're working at a large scale. Next up, data SKEW. You're probably going to hear this as a problem from a lot of people. In our case, since we're generating training data, that's based on user requests and user client events that happen afterwards. You can have bad actors in your system, people that are trying to spam certain things, or people trying to influence ranking. This happens a lot on Instagram. And my advice here would be to kind of tackle this problem as close to the source as possible. And then also think about this early on. If you have a service that depends on user behavior, users are going to have bad behavior eventually, however you define that. And so you can do things here like rate limiting requests. You can develop heuristics about what kind of data you may want to filter. We have a very good site integrity team at Instagram and Facebook. They do a lot of work here. So the point here being just think about this early on, because it's going to happen. And how this manifests when you're doing a join is you will have a join stage that has a bunch of tasks, and all of them will finish except for like 1 or 2, and that 1 or 2 will run for hours on end. And it's not the most optimal way to do this. Obviously, if you can have evenly distributed data, the better things will perform. And you can also tackle this by like repartitioning your data by a different key. If you're doing a join, that might be difficult, but there's a lot of ways you can attack this, and it's good to think about it early on. And then finally, in as many cases as possible, you would want to test on sampled data. In our case, our production data sets are quite large, and I mentioned the number of multiple hundreds of terabytes. That's for feed specifically. We have many clients that we're running pipelines for. And so when you want to validate logic in your pipeline, it's very important to have kind of subsets from production that you can test on in order to validate things. Back to the point of like testability and writing Spark pipelines, you can write a unit test that spins up Spark locally and actually validates your pipeline. So you can have like mock data, but then there's also kind of like this larger integration test you want to do with all of your systems, and it's important to have smaller tables you can test on. This doesn't always work because some issues only come up when you're running on the entire data set. So if you're like stress testing your entire infrastructure, your deployment infrastructure, your shuffle services and things like that, sometimes you need to test on the full data set, but it's a very frustrating experience to start a pipeline, let it run for 8 hours, and find out it fails at the end. That's not fun. I've done that many times. So again, just testing on sample data. And then that's basically it. I wanted to say that it's awesome that this software exists. We have, again, 800 million users. We're running this on a lot of data. We have other use cases as well that we use Spark for. Spark is used inside of Facebook as well, mostly for the Spark SQL side of things, as I mentioned, migrating from Hive to Spark. And I want to say a thank you to the open source community for working on this software. If you're interested in kind of Spark at Facebook as a whole, people from our Spark team have given talks at previous Spark summits, and I'm sure we will give more talks in the future. And they're also very active in contributing back to the open source community. So that's basically it. I wanted to say thank you for being here, and I will take any questions.
There's a microphone over here. Hi.
Hello.
My question is on the infrastructure side. You mentioned about using HDFS. Are you guys also doing some kind of object storage to store your data, or just HDFS plain?
I used HDFS as an example. We are not necessarily using HDFS, and we have a lot of different storage, different ways to store data inside of Facebook. I don't know if I can get into the details of that, but that was just as an example of just persisting intermediate data in general as a way to kind of be able to tune the independent stages of your pipeline.
All right, thanks.
Okay, if there are no further questions, thank you, Brandon, for the talk. And the next session begins at 11:40.
Thank you.